This video describes a new feature added to the General Linear Models procedure Statgraphics 19 for stepwise effect selection. The data to be considered consist of one quantitative dependent variable y and multiple quantitative or categorical factors x. We'll talk about two new features in version 19. The first is easier entry of interactions and higher order terms when you're specifying the model. The second new feature is a stepwise selection of effects. The data we're going to look at is one we've looked at in a lot of videos. It's information about 93 different makes and models of automobiles. I'm going to build a model to predict for any particular automobile the miles per gallon it'll get in highway driving. To analyze this data, I'm going to go to the top menu to Relate, and under Multiple Factors, you'll see the General Linear Models procedure. The dependent variable, the one I want to predict, is miles per gallon in highway driving. I'm going to pick drivetrain, that's a categorical factor, horsepower, wheelbase, and weight, they're quantitative factors. And I'll use those four factors to predict miles per gallon. When I press OK, the program will take me to the GLM model specification dialog. You'll see that it's entered main effects of the four factors labeled A, B, C, and D. I'd like to add some more two-factor interactions and some quadratic terms. In previous versions, you would have had to type them in manually. But now there's a new button labeled Ints, which brings up a dialog box. And all I need to do is tell it I'd like to have second-order interactions and quadratic terms, and then press OK, and it will type the necessary terms into that field for me. And you'll see it's entered two-factor interactions amongst all pairs of factors and quadratic terms for the three quantitative factors. When I press OK, the program will give me a list of tables and graphs I can create. I'll just take the defaults, and you'll see that the program has now did a model involving all of the effects. There are four main effects, 6 two-factor interactions, and 3 quadratic terms. You can also tell by the p-values that there aren't many significant effects, not by themselves. And that's not surprising because there's an awful lot of multicollinearity amongst these terms. I'm now ready to do a stepwise effect selection. I'll press the right mouse button and go to Analysis Options. And you'll see over here a section labeled Stepwise Variable Selection. Now I have two choices for the procedure I want to use. I can use either a forward selection procedure or a backward selection procedure. The forward selection procedure starts with a model with no effects and brings in effects one at a time, the most significant ones first. A backward selection starts with a model involving all of the effects and starts taking out effects, the least significant first, one at a time, until all the effects that remain are statistically significant. Now, it's slightly more complicated than that. In either the forward or backward selection, it's always rechecking to see whether effects that are brought into the model may no longer be significant and should be taken out, or whether effects taken out of the model may become significant again and should be brought back in. Now, there are a couple other fields that are important. We have P to enter and P to remove. Those are the significance levels that control when variables will be brought into the model or removed from the model. We also specify the maximum steps allowed in the selection procedure. And if we wish, we can ask the program to display each step. An additional checkbox that's quite important, particularly in cases like this, is that we retain lower order effects. If I check that box, then the program will not consider any model with higher order terms unless the corresponding lower order terms are also in the model. So, for example, it wouldn't consider models like drivetrain with horsepower unless both drivetrain and horsepower main effects were also in the model. And it would not consider a model with weight squared unless the main effect of weight was in the model. So let's go ahead and do the fit. I'm going to press OK. And it did the backward stepwise selection. Now you'll notice that the terms it retained were drivetrain, wheelbase, and weight. Interactions between drivetrain and weight, wheelbase and weight, and also weight squared. Horsepower, you may see, is nowhere to be found. If you look at the p-values, you'll notice that they're all less than 0.05, except for the one on weight. Weight is a p of 0.065, above the typical 0.05 criterion to remove from the model. However, because we have other terms involving weight, the main effect of weight is retained in the model. To see how the algorithm worked, I can scroll down and I can see what happened at each step. At step 1, the interaction of horsepower and wheelbase was removed. Then wheelbase squared was removed, then horsepower times weight, and horsepower times horsepower. You'll note at each step that the r squared is getting smaller, however the adjusted r squared is getting larger. And correspondingly, the mean squared error is getting smaller with each step. It then continues to remove other effects. For example, it removes drivetrain times wheelbase. Now, one thing to notice, when it removes drivetrain times wheelbase, error degrees of freedom goes up by 2. When it removes a categorical factor, it removes all indicator variables for that categorical factor. Likewise, if it brings in a categorical factor, it creates as many indicator variables as it needs. And finally, at the end, it got down to a model with an adjusted r squared of about 79%.